In the previous videos, we learned that in order to solve a trigonometric equation, there are two methods. The first is the graph method and the other is the quadrant rule method. Now in this video, we're going to learn special type of trigonometric equations when they're equal to 0, 1 or minus 1. And whenever there is such a case, when the trigonometric equation is equal to 0, 1 or minus 1, it's much easier to use the graph method rather than the quadrant rule method. Now let's solve this first equation, which is sine of theta is equal to 0. I am first going to solve this equation by using the quadrant rule method. Now first I am going to assume that this 0 is positive. So sine theta is equal to a positive number. Since the trigonometric function is separated out, I can replace this theta with my basic angle alpha. So replacing the basic angle would give me sine of alpha is equal to 0. Now shifting the sine function on the other side would give me alpha is equal to sine inverse of 0. Now when I use the calculator, keeping the calculator in the degree mode, sine of 0 is equal to 0. So the basic angle alpha comes out to be 0. Now since the sine function was equal to 0 and we assumed it to be positive, I'll need to draw the lines in the first quadrant and in the second quadrant, because these are the two quadrants in which the sine function is positive. And my lines in these quadrants are going to look like this. Remember, we learned that the basic angle is measured from the horizontal axis. So my first basic angle is going to be like this, alpha, which is equal to 0 degrees. So alpha is equal to 0 degrees. And my second basic angle, which is again going to be measured from the horizontal axis, is going to be like this. And since alpha is equal to 0 degrees, this means that this line should be in fact on the horizontal axis. And the second line, which also has the basic angle of 0 degrees, should also be on the horizontal axis like this. Now for the angles of theta, I'll start from here from 0 degrees and go anti-clockwise towards these lines. If I go towards the first line, the first basic angle is going to look like this. This angle is equal to the basic angle, which is 0 degrees. So my first value of theta is going to be equal to 0 degrees. Now for the second angle, I'm going to again start from 0 degrees and go towards the second line. And this second angle is alpha short of completing 1/2 cycle. So this second angle is going to be 180 degrees minus alpha, because 1/2 cycle is 180 degrees. We know that alpha is 0, so the second angle is going to be just 180 degrees. Also, since I need to measure the angles from 0 degrees up to 360 degrees, I can start from 0 degrees again and go from here up to this line here again. And this angle would be one complete cycle, which is 360 degrees plus alpha. And since alpha is 0, so the value of this angle would be 360 degrees only. And this is lying in my domain, so I can include this angle in my answer. So these are the values of theta when sine theta is equal to 0. And we found this answer by using the quadrant rule method. However, if I were to use the graph method, if I remember the graph of sine theta, I can directly look at the points at which the y value is 0 for the sine function. This is the graph of sine theta and it's 0 at these 3 points, which are 0, 180 degrees and 360 degrees. And the answer came out to be the same. Let's do the second example. Here I have sine theta is equal to 1. And here the sine function is positive. The trig function is separated out, so I can replace the angle theta with my basic angle alpha. So sine of alpha would be equal to 1. Shifting the sine function on the other side would give me alpha is equal to sine inverse of 1. And if I put this in the calculator, sine inverse of 1 is 90 degrees. So the basic angle alpha is equal to 90 degrees. So I'll draw my two lines in the first two quadrants because the sine function is positive in the first two quadrants. And my two lines are going to look like this. This is going to be the first basic angle which is alpha is equal to 90 degrees, and this is going to be the second angle, which is again 90 degrees. So when this first line is 90 degrees, this means that this angle of alpha should be in fact on the vertical axis. And when this angle alpha is 90 degrees, this means that this line should also be on this vertical axis. Now for the values of theta, I'll start at 0 degrees and go anti-clockwise towards the first line. The first angle is equal to the basic angle, so the first value of theta is going to be equal to 90 degrees. Now for the second line, if I again start at 0 degrees, this would be the second angle. This angle is 90 degrees short of 1/2 cycle. So I can say that this second angle is alpha short of 1/2 cycle, and 1/2 cycle is 180 degrees. So I can say that the second angle is 180 minus alpha. Alpha is 90 degrees, so the second angle is going to be 180 minus 90 degrees, which is just 90 degrees. So the two angles of theta are 90 degrees and again 90 degrees. But we don't repeat the same angle more than one time in our answers, so I'm going to erase this angle. Now I could start again at 0 degrees and go up to this line again. This angle would be alpha greater than 360 degrees because one complete cycle is 360 degrees. Since alpha is 90 degrees, this angle would be 360 plus 90 degrees, which is equal to 420 degrees, and this exceeds our range. So I'm not going to include this third angle. So this is my only answer for sine theta is equal to 1. Now if you remember the graph of sine theta from 0 degrees up to 360 degrees, it looks like this. And the point at which the y value is 1 for the graph of sine theta is this point over here. And this is the only point which satisfies the value of y is equal to 1. So the only answer for sine theta is equal to 1 is 90 degrees, which is the same that we got by using the quadrant rule method. And so you can see that it is much easier to use the graph method when solving equations of 0, 1 and minus 1. Similarly, for the third equation, for sine theta is equal to negative 1, I could just simply use the graph method and look at the point when the y value is negative 1, which is 270 degrees. So the answer would be only one angle, which is theta is equal to 270 degrees. This is my answer for this third example. And also it can be any trig function equal to 0, 1 or minus 1. For example, when cosine theta is equal to 0, 1 or negative 1, and when tan theta is equal to 0, 1 or negative 1, the graph method would be much faster to use and would give the answers relatively quicker. So whenever you have any trig function equal to 0, 1 or minus 1, it is much easier to draw the graph of that function in the domain given in the question and look at the points that satisfy those values.